Hey students, this is Mr. Woodward showing you how to play this up and down game in the concept builder on the Physics Classroom website and how to beat it. So this is sort of a video answer key. All right, for this first activity, a ball is launched upward from the ground. The diagram shows the location of the ball at 1 second intervals. So if the ball is launched at location A, it rises to location E and then falls back down, and location I is just before it hits the ground. So when we're ranking the ball speed, we know that the ball is going to slow down as it rises, reaching zero speed here, and speed up as it falls back down. So the maximum speeds are going to be here, the minimum speed is going to be at the top. So when we're looking at C, D, and H, well, D is the highest above ground, so D will be the smallest velocity. C is in the middle, and H is the lowest to the ground, so that's going to have the fastest speed. And then when we're looking at the acceleration, well, the acceleration of the ball is the same every moment in time. It's always changing speed by 9.8 meters per second every second. So the acceleration is all the same. And then if I do this again, looking at B, E, and G, well, G is going to be the fastest because it's just before it hits the ground right here. E is going to be the slowest because it's the highest up. It's the closest to location D. And the middle speed is going to be B. Again, these are all the same. The ball acceleration is always negative 9.8 meters per second squared. And so from A to E, the ball is rising, so those velocities are positive. From E to I, the ball is falling, so those velocities are negative. So at location D, that's going to be an upward velocity. Location E has no velocity because it's changing direction there. Location G, the ball is falling down, so it's got negative velocity. And you can see the vector here. The acceleration at all times is down because gravity is pushing the ball down at all times. C is on the rising side, so that's up. D is at the top, so that's 0. F is on the falling side, so that's down. Acceleration is always down. Okay, and it adds those vectors for me. All right, so that's the first activity. The second activity is actually connected to what I just did, except now I'm going to drag the vectors over. So let's start with the easy one. Location D, there's no velocity at location D, but it is accelerating in the downward direction because gravity is pushing the object down. So I'm going to grab this one here. Okay. Location B, the ball is rising, but it's accelerating downwards because of gravity. Location G, the ball is falling. Just before it hits the ground, it's going very fast, but it's also accelerating downward. So I have a large velocity vector pointed down and the blue acceleration vector pointed down as well. And then doing it again, so let's go with location E, where there's no velocity, only acceleration. Location F is going to have a little bit of velocity. It's like starting to speed up in the downward direction. Location A has a ton of upward velocity because it's being launched there, while also accelerating downwards as soon as the ball is released. Okay, activity 3 is now numerical. I'm going to go with negative 9.8. So let's start at the easy one, right? Location D, the velocity is going to be 0. E is 1 second later, where the ball will speed up in the negative direction by 9.8 meters per second. So it's going to reach negative 9.8 at E, F is 1 second later, so it's going to go negative 9.8 more. G is 1 second after that, so it's going to go negative 9.8 more than the negative 19.6. So it will reach negative 29.4. Location C is 1 second before location D, so the ball is rising at location C, and the velocity at C is going to be 9.8 greater than location D. So this will be positive 9.8. This will be positive 19.6 because the ball is rising at location B. This is positive 29.4. So there's a symmetry here, right? The acceleration is always negative 9.8 every moment in time. That's indicating the change in velocity each moment. And then it's going to ask me to do it once more, but now, it's in the air for one more moment in time. So the entire journey is actually 2 seconds longer. So again, starting at location E, that's where the velocity is 0. Falling after 1 second, after 2 seconds, after 3 seconds, after 4 seconds. And then location D is just 1 second before E. It's going to be going positive 9.8 there. I'm just filling out that symmetry, right? And then these are all negative 9.8. All right, let's check this out. And that is how you beat up and down, okay? Using those fundamental principles of rising and falling motion under the influence of gravity.